Okay, hello everybody again. So let's start. Today we are going to solve problems from 11 to 19 from your independent data science exam. We'll solve them in two variants. So for the beginning, let's revise what is type 1 and type 2 error, because it will help us to solve the 11th task. Type 1 is false positive error, like we did something, but the null hypothesis was true. And type 2 error is false negative. It means that we did something wrong and the null hypothesis was wrong too. For example, you decided to get tested for COVID-19 based on mild symptoms. There are two errors that could pertain a cure. So here, first type error will be the test result says you have coronavirus, but you actually don't. So the test said that we have, but actually the test have to say that we don't have. And the second type error is the test says you don't have coronavirus, but you actually do. So the test have to say that you have coronavirus, but test said another. So let's move to the first exercise. In the beginning, I advise you to read the hypothesis. In the situation 1, it is a turn is required. And the situation is a mobile robot crashed into a fence in front of it. So hypothesis said that we have to turn, but we haven't turned, and it was an error. So it is error type 1. And the second case is floss nullum flowers have exactly 4 petals. And the situation is researchers are studying the number of petals in flower of the floss nullum species using a special program. This program submitted a report saying that all flowers of this species have exactly 4 petals. In a manual review, the researchers found that in their sample, floss nullum flowers were equally like to have both 4 and 5 petals. So, because of finally floss nullum have 4 and 5 petals, the null hypothesis is false. And because of this, this error have type 2. Let's check our answers. Yep. In first situation it's type 1, and in the second situation it's type 2. So if you will have questions, feel free to interrupt me to ask them. Don't be shy. Yes, Ertin, Doptan.
So okay, in this task, is there always two options, or like there can be like type 1 situation, or type 2 type 2, or is there
Yes,
always like type 1 and type 2?
of course, because of this situation aren't connected. So in both situations, you can pass type 1 or type 2, and there is other choice that we can't recognize what is error in this exam.
Oh, okay, then I understood. Thank you.
You're welcome. So the second variant, I think that it is much more easier. So null hypothesis in first situation is the road ahead is straight, but situation is a mobile robot made a turn on a straight stretch of road and fell into ditch. So we have to ride straight, but we have turned and it was mistake. So situation was 1 is first type error again because the hypothesis was positive, but our decision is false. And sorry, let's move to the second situation. Hypothesis there is a fire has started. And the situation is a fire alarm went off, but the arriving firemen found no trace of a fire. So we thought that fire has started, according to hypothesis, but there were no fire. So in this situation, it is hypothesis type 2. And it's correct. Let's move on. For the 12th exercise, let's revise what are types of machine learning. So first type is classification. It is comfortable to use in categorizing data into predefined classes of groups. For example, define if an email is spam or not spam. So there are only two options. Clustering, grouping data points into clusters based on similarity. For example, segmentation customers based on Russian behavior, like somebody buy only bread, somebody drink water, and etc. Other type is ranking, ordering items or data by certain criteria. For example, ranking web pages based on relevance to a search query. And the last but not the least is aggression, predicting a continuous value. For example, estimating house prices based on various features. So let's start. In the first variant, analyst agent receives a large number of spam emails every day. If you want to build some kind of machine learning model that can distinguish between useful emails and spam. So we have two types. First type is email and second type is spam. Maybe somebody have some ideas what is type for this machine learning model?
Well, it seems like it's classification.
So yes, you're right. It's classification. Why it's classification?
Well, because machine's supposed to distinguish like two types and sort them kind of into groups.
Like we choose for every emails only two types, like is it spam or it's not spam. Okay, let's move to the second variant. It's researcher Anastasia wants to build a model that successfully predicts the species of animals of the culinary type. To do this, she uses a sample that contains measurements on the animals and its species for each observation. So here we have again classification because we have a pool of species which we have to predict. So everywhere when you see that you have types, like a prediction value of your model, you have to pick classification. Yeah, it's classification. Any question in this task?
Okay, why can it be a regression? Because this machine is supposed to predict kind of the type.
Because it's will not be regression, because if you remember,
Oh,
if
yeah, understood. It's not continuous. Yes, yes.
like continuous, and we have in classification we have a pool of types that's nothing from outdoors or from another topics cannot go to this pool, like we have them only 5 types, 10 types, or 100, but in regression we have continuous types. Okay, let's move on to the 13th. In this task, we have to understand what will happen with some value. So let's read the task. Meteorologist Alexander wants to estimate the dependence of the amount of precipitation, and it is our value that we are going to illustrate using this example on air temperature and wind speed using a linear model. Life experience tells Alexander that instead of the absolute value of temperature, the model should include its natural logarithm, and it is in the specification that evaluates the model. Okay, let's have a look for this formula. So perk is equal to 4 plus 0.1 of the logarithm of temp minus 0.12 to speed. Okay, let's read all answers and choose the correct one. If the air temperature increases by 1 degree Celsius, the amount of precipitation increased by about small part millimeter. So Celsius increased by 1 degree. So can you see my cursor or not?
Yes, we can see it.
Okay, so this the temperature, its meaning will increase in 1, and we'll have like logarithm of 10 plus 1 plus 1 or 1 plus 1, and it is hard meaning, so we cannot predict which increase it will happen. For example, using the Python and library math, you can count the logarithm using, okay, let's start this part to import math. Using math.log, you can count, for example, logarithm of 2. It is 0.69. And this exercise you can solve just using the Python. So in the task, it said that the air temperature increased by 1 degree. So for example, the previous temperature was 2 degree, and we can see that PERC is equal 0.1 or 0.1 multiplied to temperature. So if we want to have 0.001 millimeter increased, this whole part have to increase to 0.01. So let's just write the code like this part. 0.1 multiplied to logarithm. It's yeah. So let's check for increasing. If we will increase the temperature, we can check it like we take previous value, for example, here 2 again, and take increased in 1, so it will be logarithm of 3, and we can just run this program, and we can see that it isn't 0.001, but it is much more better to check in other values, for example, in 5 and 4. But I think that you have to remember just that one moment. This meaning x plus something or minus, we cannot just count it, because it will be different in every case. So it is wrong. Let's move on. When the air temperature increases by 1 degree Celsius, the wind speed decreased by about 0.12 meters per second. We have no correlation between temperature and speed, so it is wrong again. 1% increase in air temperature increase the amount of precipitation by about this again value. So maybe somebody will tell me how, if the previous value is x, how I can get the new value, like increased in 1%. To what I have to multiply the previous value. Okay, if we have in the beginning we have, for example, x to increase in 1%, we just have to multiply x to 1.01 because if we'll write a little bit more, it is like when we plus 1%, it is just x plus x multiplied to 0.01, and it is x multiplied to 1.01. So this sentence moves to x multiplied to 1.01, and using properties of logarithm, we can do just this. This logarithm is equal to logarithm of x plus logarithm of 1.01. So we have to calculate just math logarithm of 1.01 and multiply it to 0.1. And we can see that here is stated that precipitation, the amount of precipitation will increase in about this value. And as we can see, we can just, I think, round it. Oh, no, it's round to 4 digits. But okay, so it will be the right answer. And the last the last type, the last variant, if the wind speed increases by 1 millimeter in second, the amount of precipitation will increase in about 0.12. If we'll put here our new value, it will be speed dot e plus 1, and as we can see, if speed value increase, the whole value will decrease. Any questions here? So we can check the right answer. Yes, it is the third, the first variant. Okay, if there is no questions, let's move on. The second variant is the same task, but we have another formula for PERC. So maybe somebody wants to try to solve this exercise, and I will help him or her. Okay, I will do everything myself. So first variant, temperature increasing by 2 degrees. 2 degrees, and the amount of precipitation increased by 4 millimeter. So this temperature will move to temperature plus 2, and as we can see, we have to multiply the temperature, so the PERC will increase to 4 millimeter. it is the right answer, but let's check the others. In the square of the wind speed, E is replaced by its cube. So this square of speed will be replaced to cube. The estimate of the coefficient in front of the variable speed to E will not change in any way. So we cannot discuss about this, about the coefficient, because we changed the formula, and because of this, we have to change the whole formula final. If the wind speed increase, the amount of precipitation will decrease. So if speed increase, we can see that we have precipitation plus speed. So the whole sentence will increase too, not decrease. At any values of the attributes, the amount of precipitation is greater than 10. It's not true again, because for example, if speed will be 0 and temperature will be under 0, for example, -1, the perk will be 8. But for example, if we will have temperature in square on in the model, this variant will be right. So we have chosen the first variant, and it is correct. So any questions according to this task? Okay, let's move to the 14th task, and okay, I am going to show you the task. Here we have MSE error, my error, and in the task we have R square. So let's revise what is MSE and Maya. MSE is mean square error. As we can see, we take the mean of our all according to all our parameters, calculate the error, and to make it positive, we have to increase it in square. And the Maya, it is mean absolute error. As you can see, we just sum our errors in model. And R square is this formula. As you can see in the here, we have MSE, so it will help us in this here in this task. You have to remember these formulas to solve this task. So let's read the variance. Maximizing the R square in this model is equal to minimizing MSE. So we know the formula of MSE. So if we'll drop this part, we can see that it is equal to this. And when we are maximizing R square, so this part have to become minimized. So the MCA will, so we have to minimize an MCA. So this is correct, but let's let's move to the other options. MSE and Maya cannot consider for such model. We can use it in regression liner. R square is not an adequate measure of evaluation for this model. It's again false because we can use R square in linear regression, and for such model, we say will always be less than Maya. It's false too, because for example, if everything is correct in both MSE and Maya, we'll have zeros. And yes, the first is correct answer. And in second parent, we have, I think, the same task. We have again a linear regression and train by minimizing the MCM. So let's check the variance. Maya cannot be used to compare such models. We cannot it use because we are using we are training this model by minimizing the MSE error. Second, only MSE can be used to compare such model. It's not true because we, for example, can use R square again. R square in such a model is always greater than 0.8. Again, the same example like in previous exercise, we can just put it here. And the last variant is maximizing R square for such a model has nothing to do with minimizing MCA. Again, wrong, because in previous exercise we have this answer. So the first is correct. Okay, any questions? It is. I think that it is the hardest exercise in our amount of numbers that I am going to solve today. So you have just to revise these formulas, and with them, I think you can solve this exercise. Okay, task 15. Here we're going to use rock curve. So let's revise. What is it? Rock curve can square under the rock curve shows us the accuracy. It's one of the most important that you have to remember. And I will tell you how we can count it. It's you have just calculate the square under your curve. For example, here you have to calculate the area under this blue line, and sometimes it is much more easier to put this random line. As you can see, it's random when accuracy is 0.5. And using this line, you can just calculate your accuracy. So let's begin. First variant is on average, this logistic regression predicts better than the random classifier. We can see that random classifier is this red line, and we have our line not under upper than this line, so this type is correct. Let's check the other types. The outgrowth of this logistic regression is 0.95. Okay, let's calculate it. As you can see, the first side of triangle here. It's we can calculate it like a square, because first side is 0.3 and the second side is 0.3, so the square is 0.09, I bet. Yep, and we have to divide it to 2 because here we have only triangular. Okay, but we can do this if we want to solve this problem like how they want, but we can understand that the upper part have to be this 1 minus our AUK value. So if we have this here, this value 0.95, we can understand that the square upper than our line is much more bigger than 1 or than 0.05. For example, square of this part, like from 0.4 to 0.3 is 0.12. So this answer is not correct. The deprecated rock query is the same as the ideal classifier query. It's wrong because the ideal is this type of query where the accuracy is 1. And according to the query, if FPR is 0.6, the true positive rate is also 0.6. Let's check it. When positive rate had 0.6, we have 0.8. It's not correct. So the correct answer is first. Let's check it. Yep. Maybe somebody wants to try to solve for the second variant, and I will help if it will be hard. Okay, come on.
I cannot solve it, but I have a question.
Mhm.
How can we understand that this regression is better than classifier? Well, what shows us this that this is better or worse than random classifier?
When we can, if we are talking about better, it's a good questions because in this exercise we have, I think, a trap about this. As you can see in the here, they ask us, is this classifier? Oh, yes, is this classifier worse or better than the random classifier? But we have to remember that in classifier we can just to change the classes, and for example, here we can just change these classes to the antiviral, to the positive classes, and we'll we'll have another line that will be upper this random rock line. So I can say just that the worst classifier is when we have a rock curve like this random curve. So when we have this curve, we cannot do anything with this classifier because we cannot optimize that or change the classes to have the better rock curve. I
Okay,
answered.
I got it. Yes.
So let's try to solve this exercise.
Well, it seems like this rock curve is worse than random classifier, right? Or
As I has, have told, here we have our rock curve under the random, but we can change our classes. To be honest, I thought too that here is worse, but I asked your lecturer if I write that if we'll change here our classes, like for example, if our formula is if the value is more than 10, it is red, is less 10, that is blue. We can just opposite this regression, like if the value is more than 10, it is blue, and less is red, and our curve will change their line. So your answer is wrong. And according to this answer, the right answer is the third, that this regression is better than random classifier. You have to remember that logistic regression or other model will be worse than the classifier if it will be worse or equal when this curve is equal to this random curve. Any questions? Okay, let's check our answer, and yes, it's true. And now we are going to start programming. I will open Google Colab. So if anybody will want to take it from me, you can just type in the chat if you want me to send this presentation or Colab notebook. So let's move to the 16th exercise. Winnie the Pooh has been recording measurements of the amount of sugar in a barrel of honey for 120 days. He is certain that the obtained observation are a sample of independent, equally distributed normal random variables. So here we know that it is normal random, and we know the number of days. It turns out that the mean amount is 57, and the sample variance is 3.69, and the construct 95% confidence. So in this exercise, they ask us about the upper limit of the interval, around it 100. So let's, for the beginning, calculate this interval. We have to use library SciPy to use normal interval. So here in the first value, we put our confidence. It's 95. After this, we put the mean the mean amount. Here it's log. It's 57, and the scale we have to calculate. It is square of variance divide to square of our period. So it's square of 3.60 61 divide to square of 120. So let's run it, and we have got this interval, and in the task we have to find the upper limit, so it will be this 57 dot something, and around 200 stories. So we have to take only 2 digits after the dot, and we just run this function. Because if we'll write here 0, because this is a tuple, so if we'll write here 0, we'll have the lower, and if we'll type 1, we will have upper limit, and we'll put here 2 to round it to hundreds. Oh, yes, hundreds. So let's check our answer, and yes, it's correct. Any answers or any questions about this exercise? Here you have just to remember the function. It starts normal from library SciPy, and remember where you have to write each value. But if you know the formula, it's much more easier, for example. So if there are no questions, let's move to the second variant. Here we again have to calculate the normal interval. We just do everything like in the previous exercise. We have just other values, and we have 42 to 41. Okay, let's let's do something like this. It's okay. It's show. Okay. Any questions about the 16th exercise? There's no questions. Let's move to 17th. In this exercise, we will have to provide the test. In this variant, we have that test, but in other variant, we have that test. So here we have two regions, first region and two region. And assuming the task in this exercise is assuming that all necessary precisions are met, the variance of the general population are equal. So if there will not be equal, we have to do something with our data, and the samples are independent. The test the hypothesis of equal or the mean precisions level using the test at the 5%. So we calculate the test. Here we have 57%. Does anybody know what we have to do after this? If the task is to check hypothesis rejected or not rejected. Okay, I have written here. It's not so if our value is more than our significant level, our hypothesis is not rejected, like we can see here. So if we'll have, for example, 0.0001, which is much more smaller than 5%, the hypothesis will be rejected. Let's look for the second exercise. Here we have the same exercise, but we have to use the test with again 5 significant level. In the Z test, you have to write just like region 1, region 2, but in t-test, you do the same. I don't know what I wanted to say. So we just put our massives here, put it to the our test. It's again from SciPy library. So it is much more easier to write like here one, because write one will have the test value like immediately, and it is here 0.03. It is smaller than 5%. So the hypothesis is rejected. Any questions? Okay, let's move on. Task number 18. Here we have to calculate the correlation between the two types of data. So let's look what data we have. We have the cost of the monthly rent of the apartment. We have neighborhood category coded according to the codifier and distance from the apartment to the nearest metro station. Maybe somebody know what two variables we have to take for our correlation. Okay,
I
first,
guess we have to take the cost and the distance because a neighborhood category it's not a continuous variable.
once again, so I was looking for a question. What
I think we have to take the cost of the monthly rent and the distance from the apartment to the nearest metro because the second variable is not continuous.
Yeah, it's category, so we cannot use it. So somebody asked me to show again the 17th solution. I will send. I think I can send after this lesson. I will send the link to the Google Colab and to the file, so you can revise these exercises. So here, yeah, you said that we have to use cost and distance. Let's do this. Here is the cost, here is the distance. And to find the correlation, we have to use library stats personnel. We put our two datas, like rubbles and distance, and round it to okay, sorry. Okay, Tavador Artem, in what? In first variant or second variant? Okay, here you are. Here. Yeah, it is. I'm sorry, because I just copied it from here, not to write it again. Yes, it is S test. No, not S. Yes, Z test, because we have this value. But in both tasks, we have to compare it with alpha meaning. Yes, thank you for this. Okay, let's come back to the 18th exercise. Here we just count the correlation between rubbles and distance and round into hundreds again. Here we have 0.68 and it is correct. In the second variant, it is the same task. We have to use the same method. Maybe someone else will told me what type of data we are going to take here.
The height and the weight.
Yes, you're right. So it's a very easy exercise. You have just to find two continuous data sets and put it to function stats precision and just write round. Just remember this function. So we put here height, we'll put here weight, and we have answer 0.18, and it is correct answer. Any questions about this task? Okay, if there is no questions, let's move to the last task for today, this 19th task. And here we have to calculate the Higgs square statistic. We again have some data. You can see it here. In task said that grandmother Avdotia wants to test whether there is a correlation between the kind of pumpkin and the weather conditions in which the particular kind was planted. To do this, she collected 100 cans of pumpkin and wanted grandma wanted to make a Chi-square test about this correlation. So what we do, we look in a table, we see one class, sunny weather, we see the second class, rainy weather, we put in our data sets like this and just use the function Chi-square cognitioncy using this array. If you see, we have to use matrix. We don't use this like in previous exercise when we just put two massives here, but here we have to put these two datas in one array. So after this, we just run again this function and take an answer. It is 18.17. It is the correct answer for this exercise. And in the second second variant, we do obviously the same thing. We just find into classes, attend and did not attend, and make two arrays. And from these two arrays, we make one big arrays. It's not pumpkin. I just took it from our previous exercise. We just do the same thing. And here we get 26.47. And it is the right answer. So Be carefully when somebody asks you to calculate, when somebody wants to know something about correlation, because, for example, 18th exercise, when we have tried to find the correlation, we here, if you see, have to use Pearson's sample correlation, but in 19th exercise we have to use his square. So be careful, just remember the functions, revise after this consultation using this notebook your functions that you have to use in these exercises, and don't worry on exam. If you have any questions, you have to ask them now, because I think that it's all that I wanted to say today. It's the last slide. Yep. Any questions about these exercises? Okay, thank you for listening. Have a great Saturday evening. Goodbye.